Mercury isn't just a dead rock next to the sun. It is a world of fire, hidden ice, and it is shrinking right now. When we look at the night sky, we tend to romanticize the planets. We imagine walking on the red dust of Mars or flying through the massive clouds of Jupiter. But nobody ever talks about Mercury. It gets completely ignored. You probably picture it as a boring, burning ball, a forgotten leftover that looks just like our moon, a place where absolutely nothing happens. But the truth is much wilder. Imagine you are standing on a planet where a single day lasts longer than a whole year, a place where the ground beneath your feet is actively cracking open because the entire world is collapsing inward, a place where you can freeze to death while staring right at the sun. Today, you are going on a trip to the strangest, most unsettling planet in our solar system. You will discover exactly what happens when you get too close to our star, and why almost everything we thought we knew about this world has been completely thrown out. Buckle up. You step out of your ship and onto the surface of Mercury. Look up. The sun is 3 times larger than it appears from Earth. It dominates the black sky. The heat blasts your spacesuit instantly. It is 800 degrees Fahrenheit outside. That is hot enough to melt lead, zinc, and tin into a glowing puddle right at your boots. You are standing on a giant, inescapable oven. But wait, take a few steps backward into the deep, pitch-black shadow of a massive crater. Instantly, the brutal heat disappears. You are now freezing at minus 290 degrees Fahrenheit. How does that happen? That's a 600-degree temperature swing. It's the most extreme, violent temperature shift of any planet in the entire solar system. On Earth, the difference between day and night is maybe 10 or 20 degrees. Mercury has no real blanket. It lacks a thick atmosphere to hold the heat. Instead, what it has is called an exosphere. It's a pathetic collection of atoms so thin and sparse that they barely count. There is absolutely nothing to trap the heat. There's nothing to circulate the warmth. When the sun sets or when you step into a dark shadow, the heat simply radiates straight out into the freezing void of space. It's exactly like pulling a blanket off in the middle of a brutal winter, except the blanket was never even there to begin with. And here's the craziest part about this temperature paradox. You would never, ever expect to find water on a planet this insanely hot. But if you travel to Mercury's north and south poles, you will find solid ice, billions of tons of it. The craters at the poles are so incredibly deep that the sun never reaches the bottom. Not a single photon of sunlight has touched those crater floors in over 4.5 billion years. The ice hides there forever, perfectly frozen on a boiling world. It was likely delivered by crashing comets long ago, and it has been sitting in the dark ever since. Now, look closely at the ground beneath your feet. You will see massive, jagged cliffs cutting across the alien landscape. Some of these cliffs, called lobate scarps, stretch for over 600 miles and reach a mile into the sky. One of the biggest, called Enterprise Roops, is roughly the length of California's San Andreas Fault. But these are not normal mountain ranges formed by shifting tectonic plates like we have on Earth. They are massive, brutal scars. You are standing on a planet that is actually shrinking. Deep inside, Mercury has a giant metal heart, an enormous iron core. Over billions of years, this core is slowly losing its heat. As it cools down, it contracts and gets physically smaller. And because the core gets smaller, the rocky crust on the outside has to buckle and fold to fit the new, smaller size. Think of a fresh, plump grape drying up in the sun and turning into a wrinkled raisin. The skin folds, creases, and cracks. That's exactly what is happening to Mercury right now. You are looking at a world that is slowly crushing itself. Scientists estimate the planet has shrunk by about 4 miles in diameter so far. For a long time, researchers assumed this shrinking happened billions of years ago and then simply stopped. Mercury was supposed to be completely geologically dead, but they were wrong. In the final months of the Messenger mission, the spacecraft skimmed just 10 miles above the surface. At that incredibly low altitude, it spotted something completely new. It found tiny, fresh cracks and narrow troughs called grobens. If you try to bend a stiff piece of toast, it will snap and crack. These grobens are the cracks. They are far too small and pristine to be ancient. Mercury isn't just shrinking, it is actively shrinking and cracking right now. If you stand perfectly still in one of those valleys, you might even feel a Mercury quake rippling through the thin crust beneath you. Time itself works completely differently here. If you lived on Mercury, your birthday would come very fast, but your day would drag on forever. Mercury zooms around the sun at a blistering 29 miles per second. It completes a whole year in just 88 Earth days. Because it is so close to the sun, astronomers believed for over a century that Mercury was tidally locked. They thought it always showed the exact same face to the sun, just like our moon always shows the same face to Earth. It made perfect sense. But in 1965, giant radar observations from the Arecibo telescope proved everyone wrong. Mercury is not locked in a 1-to-1 resonance. It's locked in a strange 3-to-2 rhythm. It rotates exactly 3 times on its axis for every 2 trips it makes around the sun. Because of this incredibly bizarre spin, a full solar day from one sunrise to the exact next one takes 176 Earth days. That means a single day on Mercury is literally twice as long as its entire year. You would celebrate 2 New Year's Eves before the sun sets a single time. Let that sink in. And because the planet's orbit is shaped like a stretched-out oval rather than a perfect circle, the sun plays impossible tricks in the sky. If you stand in the right spot near the equator during the planet's closest approach to the sun, the orbital speed temporarily outpaces the rotation. You will see the sun rise in the east, then it will slow down, stop completely, and move backward toward the horizon. Then finally, it will stop again, reverse, and continue rising. You get a double sunrise. It sounds like pure science fiction, but it's just the mind-bending physics of Mercury. You might think Earth is unique because it has a magnetic field. Our magnetic field acts like an invisible shield against violent space weather. Mars doesn't have a global magnetic field. Venus doesn't have one. But tiny, battered Mercury actually does. Why? It all goes back to that giant iron core. If you could slice Mercury in half and look inside, you would find something that makes absolutely no sense. Its iron core takes up 85% of the planet's entire radius. Earth's core is tiny in comparison, making up only 15% of its volume. Mercury is essentially a giant metal cannonball wrapped in a very thin, fragile shell of rock. How did it get such an absurdly oversized metal heart? That question has haunted scientists for decades. You have to look back at the chaotic, violent early days of our solar system. The leading theory for a long time was straightforward. A giant space rock, maybe the size of Earth, smashed head-on with a young Mercury. This catastrophic crash supposedly blasted its thick, rocky outer mantle into space, leaving behind mostly the heavy metal core. It's a very satisfying, dramatic story, but it's completely wrong. When the Messenger spacecraft mapped the planet, it found lightweight, easily vaporized chemicals scattered abundantly across the surface, like potassium, sodium, chlorine, and sulfur. A massive head-on crash would have generated so much extreme heat that it would have boiled those volatile chemicals away forever. They absolutely should not be there. The new theory? Mercury was the victim of a grazing hit-and-run collision. Another planet sideswiped it. Computer simulations of this grazing impact show a terrifying scene. 2 massive bodies colliding at tens of thousands of miles per hour. Instead of a direct smash that obliterates both, the colliding planet tears through the outer crust of Mercury like a cosmic buzzsaw. It sheared off 60% of the rock, but the blow was gentle enough to leave the vital chemicals behind. The debris formed a massive ring of vaporized rock that eventually drifted away. It's a cosmic crime scene that we are still trying to piece together. Because of that giant core, part of it is still liquid today. As that liquid metal sloshes around deep underground, it generates a magnetic field, but it's totally lopsided. The magnetic center is shifted far to the north by nearly 20% of the planet's radius. Because of this weak, crooked shield, the incredibly violent solar wind slams directly into Mercury's southern hemisphere. It knocks atoms right off the surface and physically alters the chemistry of the South Pole over billions of years.